Basic concepts in geometry. Here you can see in this white rectangle square, you can see there are dots. These are dots. And the artist, Rangoli artist, he makes use of such dots in order to draw certain figures. Now he can draw a square like this, or he can draw a triangle like this. So a straight line. First of all, he needs to draw a straight line like this, or he can draw another straight line like this, joining dots. What are points? A point is shown by a tiny dot like this. A pen or a sharp pencil. A pen, you can make use of a pen or a sharp pencil to make the dot. In this block, you can see 3 points. 1, 2, 3. These points are named. A capital P is used in order to name this point. This point is named using a capital P. This point is named using a capital A. And here the third point is named using capital T. Points are always named with capital letters. You cannot make use of small a for denoting a point. This is not a point. You cannot denote a point by small a or small b. No, this is not allowed. We can make use of capital A, capital B. So, for instance, this is capital B. This is allowed. The names of dots or points are capital letters. Line segments and lines. Take 2 points A and B on a sheet of paper. Suppose you have point A here, point A, and point B on a sheet of paper. Then, making use of a ruler, you can join them. You place a ruler here. Suppose this is the ruler. You join, take a pencil, with the help of a pencil you draw a line over here. You can connect the 2 points A and B. So point A and point B, if they are connected, you get a line segment. This is known as a line segment. AB is a line segment. We can extend the line in both the directions till the edge of the paper. You can extend it till the edge of the paper. So if the paper is very big, you get a very long line. If it is small, then you get a small line. How long can the line be? It can go up to infinity. It can go up to infinity, no end. There can be no end to this side and no end to this side. Then this is known as a line. A line does not have any end. It can be produced on both the sides. Then it is known as line AB. Whereas segment AB is the short distance which is measurable. AB, you can measure AB. This is known as a segment. Segment AB is measurable. You can measure in centimeters or meters. So that is a segment of a line. Segment means part of the line. Whereas line does not have any end. It can extend to both the sides. Here we have segment AB. It is limited from this point A up to point B. You can measure the distance. But line AB is, it extends to both the ends, to the left and to the right it extends. So it has no end. So line AB is very, very big. Let's imagine that we can extend this line forever. Suppose you have AB, 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 line AB. You can go on extending it forever without any limits on both the sides. To show this extended line on paper, we make use of arrowheads. We cannot go on extending because we have limit on the paper. Paper size is limited. So in order to show that it is very long, we make use of arrowheads like this. That means the line can be extended further up to infinity without any end. So in order to represent a line, we make use of arrowheads. So we have line AB over here, line AB. This is line PQ. The arrowheads, this arrowhead means the line can be extended to this side up to infinity without any end, and this can be produced in this direction. It can extend up to infinity, very long distance which has no end. So this is line AB, this is line PQ. Now PQ, there is L over here, L. What does it mean? It is a line L with points P and Q marked on it. PQ will form the segment of the whole line. It is part of the line. It is measurable. Rays. What are rays? Rays starting from the sun go forward in all directions. Light rays from the torch also start from a point and go forward continuously in one direction. So, sun is the source of light. The light is coming from here. The light is coming from here. It goes up to infinity. So the sun is very, very far away from the earth. Still, the light is reaching the earth. So, any thing, a line coming, it can be represented by a line. So, we show arrowhead in order to show that it can go up to infinity or very long distance. But it is having a starting point. The sun is the starting point. So starting point can be represented by a dot, and the line can be represented by an arrowhead over at the end. So one end having a dot and the other end having an arrow represents a ray. So this is known as a ray. This is the source of light. Sun is the source of light. Source means light is coming from the sun. Torch, the light is coming from this bulb of the torch. So you can see this is represented by an arrow. Here also you have an arrowhead showing that the light can go up to infinity. So a ray of a light has a dot as the source. This is the source of energy or light, and this extends up to infinity. So this is a ray. A ray has a source point and arrowhead to show that it can go up to a very long distance which is not measurable. So this is a ray. So what is the definition of a ray? A ray is a part of a line. It starts at one point and goes forward continuously in the same direction. The starting point of the ray is called the source or the origin. This is the origin and this is the starting point, and it is moving forward in one direction only. Here suppose we call this point as P. So P is the origin and arrowhead is infinite in the direction of Q, PQ. So PQ forms the ray PQ. The arrowhead represents that the ray is moving in one direction only. This is ray PQ. It has the source P, and from the source it is moving in the direction of Q and it goes further up to infinity. So ray will always be read as PQ. You cannot call it as QP ray. It is not QP ray. It is PQ ray. This is PQ ray. But if you call this as Q and this point as P, if Q is the source and you have this arrowhead over here, then QP can be called as the ray QP. Ray QP. But here Q will be the source of light. And P, further down P, you will be having the arrowhead. So the ray is traveling from source Q to P and further. Then you can call it as ray QP. Now activity 1. Draw a point on the blackboard, and every student now draws a line that passes through that point. So let us draw a point P. Now each student will draw a line passing through point P. So one student will draw like this. Another student may draw like this. Another student will draw a line like this. Another may draw a line like this. So you can start from anywhere to draw a line. Infinite numbers, you can have closer points as well. So from each point you can draw a line. So you can draw many lines passing through a same point P. So infinite number of lines can pass through a single point P. Activity 2 is also similar to activity 1. In activity 1 you draw the point and lines on blackboard, and in activity 2 you are doing it on the paper. So we can conclude an infinite number of lines can be drawn through a single point P. Any number of lines. You can draw like this, you can draw like this, you can go on adding many number of lines. So an infinite means many lines can be drawn through a single point, one point. This point is known as a point of concurrence. Point P is known as a point of concurrence. Concurrence means all lines passing through that single point. And all these lines are known as concurrent lines. All such lines passing through a single point are known as concurrent lines. There are 9 points in this figure. This figure having 9 points. 1, 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are 9 points in this figure. You can name them. You can name these points, but you make sure that you use capital letters: A, capital A, capital B, capital C, D, P, Q. You can give any other name also: R, S, T. So these are the points. You can name differently also. One and only one line can be drawn through any two distinct points. Suppose we have point A. Suppose this is the point A and this is the point B. So only a single line can be drawn through these 2 points. One and only one line can be drawn through. These are 2 distinct points, point A and B. Now you can take these points as point P and point Q. Even here you can draw only one and only one line passing through points P and Q. Similarly, you can draw lines passing through these 2 points, this and this. Only one line can pass through these 2 points. Three or more points which lie on a single straight line are said to be collinear points. Now in this diagram, let us find out which are such points. There should be at least 3 points, 3 or more. Now 3 points, you can get 3 points lying on the same straight line. So suppose this is point A, B and C. Points A, B and C are lying on the same straight line. If you produce it further, point D does not lie on the same line. So point D is not collinear with points A, B and C. Points A, B and C are collinear. That is, they are lying on the same straight line. Point D is not collinear because it is not lying on the same point. Now, these are the 3 points lying on the same straight line. Are there 4 points lying on the same straight line? Let us try to find out. So, if you draw a line starting from, suppose you name this as point A, B, C and D. These are the points which we have named as A, B, C, D. Suppose you draw a line joining A, B, it will go through C and it will also pass through D. That means all these 4 points are collinear. All the 4 points are lying on the same straight line. Therefore, all the points A, B, C, D are collinear. Point P is not lying on the same straight line. So, point P is not collinear. Point A, B, C, D are collinear, but point P is not collinear with A, B, C, D. Planes. What are planes? This is a flat surface. The tabletop is a flat surface. The blackboard is also a flat surface. Whereas this is a curved surface, it is not a flat surface. So these are planes. This is known as a plane. This is also a plane. This also is a plane. This is a plane. This is also a plane. This plane is named as H, plane H. In mathematics, a flat surface is called a plane. In mathematics, a flat surface is called a plane. It is very important, you have to remember it. In mathematics, a flat surface is called a plane. This is the definition of a plane. It can be given a name H, or it can be given another name also A. You can call it as plane A also, or you can call it as a plane B also. These arrows means that it is a plane. It can be extended. This line can be extended infinitely. This also can be extended. This line can move in this direction infinitely. So however, these arrows are often omitted for the sake of convenience. We cannot go on showing these arrows, but when we just draw a rectangle or a square, it means that it is a plane. You name it as P, then it is a plane P. Or you have another plane B, this is a plane B. Parallel lines. What are parallel lines? You observe the lines. How many lines are there? 1, 2, 3, 4. Many lines are there. Just a minute. We will count those lines. These two red lines, this one and this one, they are parallel. They do not meet at this end, neither they meet at this end. They are running parallel throughout the length. Even suppose you call this as line A, this as line B. These two lines are also parallel lines. This is going this way and this way. These are parallel lines. Line A and line B are parallel lines. They do not meet each other. These lines are meeting each other. These lines are meeting each other. But line A and line B, they are not meeting each other. Line C also is not meeting. So line A, B, C are parallel lines. Even the red lines, line A, B, C are parallel to the red lines also. You can name this as P and this as Q. So A, B, C are parallel to P and Q. All these lines, line A is parallel to B, line A is parallel to C, line B is parallel to C, line Q is parallel to A, line Q is parallel to B, line P is parallel to A. So these are all parallel lines. None of these lines meet each other. These two lines, they are meeting in this point. Meeting in this point means they are intersecting. These two lines intersect each other. So they are not parallel lines. Lines which lie in the same plane but do not intersect are said to be parallel to each other. So this is the definition. What is the definition of parallel lines? Parallel lines. What is the definition? Lines which lie in the same plane but do not intersect are said to be parallel to each other. Do not intersect. Lying in the same plane, lie in the same plane. This is the first condition. Second condition is they should not intersect each other. These lines are known as parallel lines. Write the proper term, intersecting lines or parallel lines. So here we have got the point of intersection. So these are intersecting lines. You write here intersecting lines. These lines, they are not this and this. These two lines, they are not intersecting. So they are parallel lines. You can write parallel lines over here. What about these two lines? Suppose you produce it further down. At one point which is not in the this paper, it is not possible to these lines to intersect in a point on this paper. But if you extend it further, suppose had this been a very big paper, suppose you have these two lines. Now let us consider these two lines. These two lines. Now they have not intersected, but we can understand that they will intersect if produced further. So let us produce it further. Let us produce it further. So we can have an intersecting point further down. So this pair is also having, they will intersect further down if produced. So these are intersecting lines. So you can call them as intersecting lines. Intersecting, you can write intersecting over here, parallel over here, intersecting over here. These are intersecting in this point. These two lines are not intersecting, so they are parallel. These two lines, they may intersect if produced further, so they are intersecting lines. Now the children here on the playground, they are playing kho, and there's a line, thick line drawn over here on which they are sitting. So the players sitting on this line are all collinear. So the players who are sitting are in collinear position. But these two players, they are away from the line, they are not on the line. So they are non-collinear with this line. So this is a collinear set, and these are not collinear with this given set. This is a group of stars known as a constellation. Now in this constellation, we have to find out which points are collinear. For calling it as collinear, we need at least 3 points. So we can see that these 3 points, they are lying in the same straight line. So they are collinear. Can it be the fourth point be collinear with it? Yes. The fourth point is also collinear because it is also lying on the same line. So all these 4 points are collinear points. Suppose you join this point with this point, it is not collinear. These 2 points are not collinear with any of the points. These two are not collinear. These two are also not collinear. You can't get collinear. For deciding to be collinear, we need at least 3 points. So here There are 4 points lying on the same straight line, so all the 4 points are collinear. Only 2 points are lying on this line, so you cannot call these 2 points as collinear.